below. In this lecture we will find the area of the green shape. In the drawing we have triangle ABC. We know that angle BAC, this angle is equal to 60 degrees. We also know that BF equals to CF equals to DF and equals to EF. So all those sides are equal to each other, and we also know that triangle BDF, the area of triangle BDF, this triangle is equal to 8 units, and the area of triangle FEC is equal to 15 square units. And we want to find out the area of this green shape or the area of this quadrilateral. Okay, so first of all we will define angle ABC as B and angle ACB, this angle will be defined as C. We have a rule, I will call it rule number 1. Rule number 1 states that the sum of the angles on a triangle is equal to 180 degrees. Again, the sum of the angles in any triangle is equal to 180 degrees. So I will read rule number 1 again. Rule number 1 states that the sum of the angles in any triangle is equal to 180 degrees. So according to rule number 1, this rule, the sum of the angles in triangle ABC is equal to 180 degrees. That is to say, angle A that equals to 60 degrees plus angle B plus angle C equals to 180 degrees according to rule number 1. So angle A that is 60 degrees plus angle B plus angle C equals to 180 degrees according to rule number 1. So here we will subtract 60 degrees from this equality, and we will get that B plus C equals to 180 degrees. Okay, B plus C equals to 180 degrees. Then we have also rule number 2. Rule number 2 states that in front of equal sides in the triangle, there are equal angles. So I will read rule number 2 again. Rule number 2 states that in front of equal sides in the triangle there are equal angles. So actually, if we have triangle ABC, and we know that side AB equals to side AC, then according to rule number 2, angle ABC will be equal, angle ABC will be equal to angle ACB. Why? Because in front of equal angles, those two sides are equal to each other. In front of equal sides, there are equal angles. Side AC is in front of angle ABC, and side AB is in front of angle ACB. Therefore, those two angles that are located in front of equal sides, they are also equal to each other. So angle ABC equals to angle ACB. Those two angles are equal to each other. So actually, we can implement rule number 2 in our drawing. In triangle BDF, in triangle BDF, we know that DF equals to BF. Okay, those two sides are equal to each other. DF equals to VF. So actually, in front of side DF of triangle BDF, we have angle B. So in front of side BF, we have angle BDF. So according to rule number 2, those two angles must be equal to each other. So if this angle is B, then this angle must be also equal to B. So if those two sides are equal to each other, then those two angles will also equal to each other. So if this angle is B, then this angle is also B. Okay, and we will do same thing in triangle FEC. In triangle FEC, we know that FE equals to FC. Side FE of triangle FEC equals to side FC. So in front of side FE we have angle C. So in front of FE, side FE, we have angle C. In front of FC we have angle FEC that also must be equal to angle C because of rule 2 that states that in front of equal sides there are equal angles. So those two angles are located in front of equal sides, therefore according to rule number 2, they also must be equal to each other. So if this angle is C, this angle must also be equal to C. Okay? So in the next step we will define angle DFB SP and we'll define angle EFC SQ. Okay? Then we will find out the values of angles P and Q in terms of B and C. Okay, so we know that the sum of the angles in triangle BDF equals to 180 degrees. That is to say, B plus B plus P equals to 180 degrees. B plus B is 2B plus P equals to 180 degrees. Okay? So, the sum of the angles in triangle BDF equals to 180 degrees. That is to say, 2B plus P equals to 180 degrees. Here we will subtract from this equality 2B, and we will get that P equals to 180 degrees minus 2B. Okay? So P equals to 180 degrees minus 2B. And we will do the same process in triangle FEC. We know that the sum of the angles in triangle FEC, as it is in any triangle, is equal to 180 degrees. So C plus Q equals to 180 degrees according to rule number 1, or 2C plus Q equals to 180 degrees. Okay, the sum of the angles in triangle EFC equals to 180 degrees. That is to say, 2C plus Q equals to 180 degrees. Here we will subtract from this equality 2C, and we will get that Q equals to 180 degrees minus 2C. Okay? So we got the values of P and Q in terms of B and C. In the next step, we will add together P and Q, and we will get that P plus Q P plus Q, that is equation number 2, P plus Q equals to 180 degrees plus 180 degrees is 360 degrees minus 2B minus 2C. Okay, so equation number 2 states that P plus Q equals to 360 degrees minus 2B minus 2C. Here we will take minus 2 as a common factor of this expression, and we will get that P plus Q equals to 360 degrees minus 2, in the brackets we will have B plus C. Okay, we took we took minus 2 as a common factor of this expression. We got this equation number 2, that b plus q equals to 360 degrees minus 2b plus c. But we have already found out that b plus c, according to equation number 1, b plus c equals to 120 degrees. Okay, so actually we can substitute b plus c by 120 degrees from equation number 1, and we will do it, and we will get in equation number 2 that p plus q is equal to 360 degrees minus 2 times b plus c. According to equation number 1, b plus c equals to 120 degrees. So we'll substitute b plus c by 120 degrees. And 2 times 120 degrees is 240 degrees. So we will get that p plus q is equal to 360 degrees minus 240 degrees. Okay, so p plus q is equal to 360 degrees minus 240 degrees is 120 degrees. So we found out that p plus q equals to 120 degrees, and also b plus c is also equal to 120 degrees. Okay. Both b plus c and also p plus q equals to 120 degrees. Okay, so in the next step we will find out the size of angle EFD. We will find out the size of angle EFD, this angle. We have actually, according to rule number 3, we will find out the value of this angle. Rule number 3 states that the sum of the angles on a straight line is equal to 180 degrees. So I will read rule number 3 again. Rule number 3 states that the sum of the angles on a straight line is equal to 180 degrees. So according to rule 3, we know that BC is a straight line, so if we focus at point F, according to rule number 3, the sum of the angles at this point, because of the fact that BC is a straight line, the sum of the angles must be equal to 180 degrees. That is to say, P plus Q plus angle DFE, this angle, must be equal to 180 degrees, according to rule 3. Again, according to rule 3, P plus Q plus angle, the size of angle DFE, must be equal to 180 degrees according to rule 3. But we have already found out that P plus Q according to equation number 2 equals to 120 degrees, so we can substitute P plus Q by 120 degrees. So 120 degrees plus angle, the size of angle DFE, equals to 180 degrees. So here we will subtract 120 degrees from this equality, and we will get that angle DFE equals to 180 degrees minus 120 degrees is 60 degrees. So we found out that the size of this angle is 60 degrees. The size of angle DFE is 60 degrees. In the next step, we'll connect together points D and E by a straight line. We connected together points D and E by a straight line. And again, we have here triangle, we created triangle DEF. So in triangle DEF, this triangle we know that DF equals to EF. It is given us in the question that DF, side DF of triangle DEF equals to side EF. Okay, we know that DF equals to EF. So according to rule number 2, in front of equal sides there are equal angles. So actually, if we define this angle as angle FDE as Y, then according to rule number 2, in front of equal sides there are equal angles. So we have angle Y in front of side FC, or FC is in front of angle Y. So according to rule number 2, in front of side DF we have this angle, and this angle must be also equal to angle Y, because of the rule number 2 that states that in front of equal sides there are equal angles. So in front of those two sides that are equal to each other, we have equal angles. Those angles are located in front of equal sides, therefore they are equal to each other. So if this angle is Y, this angle also must be equal to Y. Okay? So now we will continue to focus on triangle DEF. We know that the sum of the angles in triangle DEF equals to 180 degrees according to rule number 2. So y plus 60 degrees equals to 180 degrees, or 2y plus 60 degrees equals to 180 degrees according to rule number 1. The sum of the angles in any triangle is equal to 180 degrees. Therefore, in triangle DFE, the sum of the angles is equal to 180 degrees. That is to say, 2y plus 60 degrees equals to 180 degrees. Here we will subtract from this equality 60 degrees, and we will get that 2y equals to 180 degrees minus 60 degrees is 120 degrees. So here we divide this equality by 2, and we will get that y equals to 120 degrees over 2 is 60 degrees. So the size of angle y is 60 degrees. So this angle y is 60 degrees. And also this angle y equals to 60 degrees. So we actually found out the triangle DEF is an equilateral triangle because all its angles are equal to 60 degrees. Therefore, the sides of an equilateral triangle, all the sides of an equilateral triangle are equal to each other. So this side equals to this side equals to this side. So if we know that all the lines, all the sides that are marked in 2 lines are equal to each other. So if BF equals to X, we define BF as X. We define BF as X. So if BF equals to X, then FC must also equals to X, and also FE must be equal to X, DF must be equal to X, and DE must be also equal to X. Okay? In the next step, we will find out the sizes of angle ADE in triangle ADE and angle AED in the same triangle, triangle AED or ADE. Again, according to rule number 3, that states that the sum of the angles on a straight line is equal to 180 degrees. Okay? So actually AB is a straight line. Therefore, if we focus at point D, according to rule number 3, the sum of the angles must be equal to 180 degrees. So B plus 60 degrees plus angle ADE must be equal to 180 degrees according to rule number 3, because AB is a straight line. Okay, and according to rule number 3, the sum of the angles on the straight line is equal to 180 degrees. Therefore, angle B plus 60 degrees plus angle ADE must be equal to 180 degrees, again according to rule number 3. So we will subtract beta and also 60 degrees from this equality, and we will get that angle ADE equals to 180 degrees minus 60 degrees is 120 degrees minus B. Okay, angle AD equals to 120 degrees minus B. We have equation number 1 that states that B plus C equals to 120 degrees. So we'll subtract B from equation number 1 and we will get that C equals to 120 degrees minus B. 120 degrees minus B equals to C. So here 120 degrees minus B equals to C. So 120 degrees minus B in this equality equals to C according to equation number 1. So we actually found out that angle ADE equals to C. Angle ADE equals to C. So this angle ADE equals to C. Okay? In the next step we will repeat on the same process on the other side of triangle ABC. We actually will focus on triangle ADE and because we want to find out the value of angle AED. But we know that AC, side AC is a straight line. It is actually a side of triangle ABC. The side of any triangle is a straight line, of course. So angle AC is a straight line. And again, according to rule number 3, the sum of the angles on a straight line is equal to 180 degrees. So if we focus on point E, the sum of the angles must be equal to 180 degrees. So angle C plus 60 degrees plus angle AED must be equal to 180 degrees according to rule number 3 that states that the sum of the angles on a straight line equals to 180 degrees. So we got this equality that C plus 60 degrees plus angle AD equals to 180 degrees. So we will subtract 60 degrees and C from this equality and we will get that angle AED equals to 180 degrees minus 60 degrees is 120 degrees minus C. And again, we have equation number 1 that states that B plus C equals to 120 degrees. So if we subtract from equation number 1 C, we will get that B equals to 120 degrees minus C. So we found out that 120 degrees minus C equals to B. Here 120 degrees minus C equals to B according to equation number 1. So from this equality we can derive that angle AED equals to B. Angle AED equals to B. So this angle equals to B. So actually triangles ABC and this triangle ADE has exactly same angles, and we will prove that those two triangles are similar to each other. So in triangles ABC and triangle ADE, we know that angle AED of triangle ADE equals to angle ABC of triangle ABC, and both those two angles are equal to B. Okay, both those two angles are equal to B. Again, angle AED equals to angle ABC, and both those two angles are equal to B. Okay, and also angle ADE in triangle ADE, this angle ADE is equal to angle ACB in triangle ABC, and both those two angles are equal to C. Okay, again, angle ADE in triangle ADE equals to angle ACB in triangle ABC. Both those two angles are equal to C. And also, this angle that equals to 60 degrees is a common angle. It belongs both to the small triangle, triangle ADE, and angle. This angle also belongs to the big triangle, triangle ABC. So we can write down that angle A equals to angle A. It is actually a common angle because it belongs to both triangles. Okay, angle A equals to angle A. So we actually proved that all the angles of triangle ABC are equal to all the angles of triangle ADE. Therefore, we proved that triangle ABC is similar to triangle ADE. Okay, triangle ABC is similar to triangle ADE according to angle similarity rule. Okay, triangle ABC is similar to triangle ADE according to angle similarity rule. Angle similarity rule states that if two triangles are equal to all the angles in one triangle is equal to all the angles of the other triangle, then those two triangles are similar to each other according to angle similarity rule. So we have rule number 4 that relates to similar triangles. according to rule number 4, the ratio between the areas of similar triangles is equal to the square ratio of the corresponding sides. I will read rule number 4 again. Rule number 4 states that the ratio between the areas of similar triangles is equal to the square ratio of the corresponding sides. Okay, so actually, according to rule number 4, the ratio between the area of triangle ABC, or the area of triangle ABC, actually this is the sign for the area of a triangle. So this sign means that is the area of triangle ABC. So the area of triangle ABC over the area of triangle ADE, that is the ratio between those two similar triangles, that is the ratio between the areas of those two similar triangles. The ratio between the areas of those similar triangles is equal to, according to rule number 4, equals to the square ratio of their corresponding sides. And the square ratio of their corresponding sides is actually BC squared, that is the side of triangle ABC, BC squared over AD squared. DE is the side of triangle ADE. So again, the ratio between the area of triangle ABC to triangle ADE, or the area of triangle ABC over the area of triangle ADE, equals to BC square over DE square, according to rule number 4. Okay, the ratio between the areas of similar triangle is equal to the square ratio of their corresponding sides. That is to say, the area of triangle ABC over the area of triangle ADE equals to BC square over DE square. Okay, but what is the value on BC? BC equals to x plus x, so BC equals to 2x, and BC squared is 2x squared, 2x squared over DE squared. DE equals to x, so DE squared is x squared. So in total we got that the area of triangle ABC over the area of triangle ADE equals to 2x squared over x squared. 2x squared is 4x squared over x squared. 4x squared over x squared is 4. Okay, 4. So the ratio between the area or between the ratio between the area of triangle ABC to the area of triangle ADE is equal to 4, or if we multiply this equality by the area of triangle ADE, we will get the equality that states that the area of triangle ABC equals to 4 times the area of triangle ADE. Okay. In the next step, we'll calculate the area of the quadrilateral BDEC. The area of quadrilateral BDEC equals to the area of triangle ABC minus the area of triangle ADE. As you can see from the drawing, the area of quadrilateral BDEC equals to the area of triangle ABC minus the area of triangle ADE. Okay, so I'll write it down. The area of the quadrilateral BDEC equals to the area of triangle ABC minus the area of triangle ADE. But we have already found out that the area of triangle ABC equals to 4 times the area of triangle ADE. Okay, so we can substitute here in this equality the area of triangle ABC by 4 times the area of triangle ADE. Okay, so the area of quadrilateral BDEC equals to 4 times the area of triangle ADE minus the area of triangle ADE. So we got that the area of quadrilateral BDEC equals to 4 times the area of triangle ADE minus the area of triangle ADE. 4 times the area of triangle ADE minus 1 times the area of triangle ADE equals to 3 times the area of triangle ADE. So the area of quadrilateral BDEC equals to 3 times the area of triangle ADE. Okay, the area of quadrilateral BDEC equals to 3 times the area of triangle ADE. And we also found that the area of triangle ABC equals to 4 times the area of triangle ADE. Okay, so in the next step I will show you, will present to you a new formula to calculate the area of any triangle. So if we have triangle ABC, and we know that the size of side AB is A units and the size of side AC is V units, and the angle between side AC and side AB of triangle ABC is theta. Then the area of this triangle ABC, equals to A times B times sine theta over 2. Okay, so that is the area of triangle ABC. You can use it in any triangle. Again, the area of this triangle ABC, equals to A times B times sinus theta over 2. So we actually can use this formula in order to calculate the areas of triangles EFC and triangles DBC, although we know that the area of triangle EFC is 15 square units and the area of triangle DBC is 8 square units. We will use the formula for the area of the triangle in order to express the area, this area that is 15 square units, by its formula. Okay, so actually the area of triangle EFC equals to 15 square units, and the area of triangle DBF equals to 8 square units. So we divide those two areas. We'll divide the area of the big triangle by the area of the small triangle, and then we will use the formula that I stated, that I presented to you, that the area of the triangle, this triangle, equals to A times B times sinus theta over 2. We'll use this formula in order to find the area of those two triangles. So the area of triangle EFD, according to the formula that I presented to you, will be equal to x times sine q over 2. Okay, x times x is x squared times sine q over 2, and the area of triangle DBF, according to the formula that I presented to you, will be also equals to x times sine p over 2, or x squared times sine p over 2. Okay, so the area of the big triangle is 15 units, and the area of the small triangle, the area of the big triangle is 15 square units, and the area of the small triangle is 8 square units, and this equality states that the area of the big triangle equals to x squared times sine q over 2. That is the formula for the area of any triangle that I presented to you, and the area of the small triangle that equals to 8 square units is expressed by the formula that I presented to you. It equals to x squared times sine p over 2. Okay, so here we will move 2 to the numerator, and x squared times sine p to the denominator, and we will get that 15 over 8 equals to 2 times x squared times sine q over 2 times x squared times sine p. Okay, so here we have 2x squared over 2x squared is 1, so 2x squared actually cancelled, and what is left after we cancel 2x squared is that sine q over sine p equals to 15 over 8 okay, sine q over sine p equals to 15 over 8. Okay, but we have already found out that q plus p, according to equation number 2, equals to 120 degrees. Q plus p equals to 120 degrees. If we subtract from equation number 2p, we'll get that q equals to 120 degrees minus p. So actually we will substitute q in this equality by 120 degrees minus p. Okay, so we will get that sine q, instead of q, we will write down 120 degrees minus p over sine p equals to 15 over 8. Okay, so sine 120 degrees minus p over sine p equals to 15 over 8. Here I will present to you trigonometric identity that we will use in order to find out the value of sine 180 degrees minus p. So the trigonometric identity is for sine a minus b sine a minus b equals to sine a times cosine b minus sine b times cosine a. Okay, again sine a minus b equals to sine a times cosine b minus sine b times cosine a. Okay, so we'll use this trigonometric identity in order to calculate the value of sine 120 degrees minus p. So sine 120 degrees minus p will be equal to sine 120 degrees times cosine p minus sine p times cosine 120 degrees. Okay, it equals to sine 120 degrees equals to root 3 over 2 times cosine p minus sine p times cosine 120 degrees. Cosine 120 degrees is minus 1 over 2 times sine p. So here we have minus times minus is plus. So it is actually will be equal to root 3 over 2 times cosine p plus 1 over 2 times sine p. Okay, so we found out the value of sine 120 degrees minus p equals to root 3 over 2 times cosine p plus 1 over 2 times sine p. So we'll substitute sine 120 degrees minus p by this expression that equals to sine 120 degrees minus p. And we will get that sine 120 degrees minus p is actually equals to root 3 over 2 times cosine p plus 1 over 2 times sine p over sine p equals to 15 over 8. Okay, so in total we got this equality root 3 over 2 cosine p over sine p is cotangent p, and sine p over sine p is 1 is cancelled, sine p is cancelled. Okay, so I write it down. Root 3 over 2 times cosine p over sine p is cotangent p, and what is left here is plus 1 over 2 equals to 15 over 8. Okay, we got this equality. Here cotangents equals cotangents p equals to 1 over tangents p. Again, the trigonometric identity states that cotangents of p equals to 1 over tangents p. Okay, we will use this trigonometric identity and we will substitute cotangents p by 1 over tangents p. We will get that root 3 over 2 times cotangents p equals to 1 over tangents p according to this trigonometric identity. Here we have 1 over 2, 1 over 2 is 4 over 8 equals to 15 over 8. So here we will subtract 4 over 8 from this equality, and we will get that root 3 over 2 times tangents p equals to 15 over 8 minus 4 over 8. Okay, so here 15 minus 4 is 11, so I'll write it down. Root 3 over 2 times tangent p equals to 11 over 8. Okay, here we will multiply this equality by tangent p. So root 3 over 2 equals to 11 over 8 times tangent p. Here we will multiply this equality by 8 and then we will divide it by 11 in order to find out the value of tangent p. Okay, actually tangent p will be equal to 8 times root 3 over 2 times 8 times root 3 over 2 times 11. Okay, and 8 over 2 is 4, so actually tangent p equals to 4 times root 3 over 11. So we found out that tangent p equals to 4 times root 3 over 11. As you might know, that tangents is function that for the relationship between the sides of a right triangle. So if you have a right triangle, and this angle is angle P, then tangent P is actually the relationship between the sides, the side that in front of angle P, that is actually 4 times root 3, and between the side that is in front of angle P over the side that is near angle P, that is here 11. Okay, so here tangent P equals to 4 times root 3 over 11, exactly what we have here. And the hypotenuse of this triangle is actually the square root of 4 times root 3 square plus 11 square, according to the Pythagoras theorem that states that the square of the hypotenuse equals to the sum of the square of the perpendiculars. Okay, so if we want to find out the value of sine P equals to the side that is in front of angle P, that is actually 4 times root 3 over the hypotenuse, that is actually root of 4 times root 3 square is 48, and and 11 square is 121. 121 plus 48 is 169, and the root of 169 is 13. So in total we got that the hypotenuse equals to 13 units, and sine p equals to 4 times root 3 over 13. Okay, so again, the sine p equals to 4 times root 3 over 13. Okay, so actually now we can calculate again the area of triangle BDF according to the formula that I presented to you. The area of triangle BDF, that equals actually to x square units, equals to x times sine p over 2. So x square times sine p over 2 equals to the area of triangle BDF, that is actually 8 square units. Again, the area of triangle BDF of triangle BDF equals to x squared times sine p over 2. And we know that the area equals to 8 square units. And that is the formula for the area. Okay? So, here we already know the value of sine p. So, we will substitute sine p by 4 times root 3 over 13. This is actually x squared over 2 times sine p is 4 times root 3 over 13, all equals to 8. 4 over 2 is 2, so we get that x squared times root 3 over 13. 4 over 2 is 2, so it is 2 times root 3 over 13 equals to 8. Here we will divide this equality by 2, and we will get that x squared times root 3 over 13 equals to 4. So here we will multiply this equality by 13, and then we will divide it by root 3 in order to get the value of x squared. Okay? So 13 times x squared equals to 13 times 4 is 52, and 52 over root 3 is 52 over root 3. So we got that the x squared equals to 52 over root 3. X squared equals to 52 over root 3. Now we will calculate the area of the equilateral triangle EDF. Okay, the area of the equilateral triangle EDF, according to the formula that I presented to you, equals to x times x, that is x squared, times sine 60 over 2. Sine 60 is root 3 over 2, and root 3 over 2 over 2 is root 3 over 4. So in total we got that the area of triangle EDF equals to root 3 times x squared over 4. Okay, we found out that the area of triangle, the equilateral triangle EDF equals to x squared times root 3 over 4, but we have already know that x squared equals to 52 over root 3, so we can substitute x squared by 52 over root 3, and we will find out the area of triangle EDF. So the area of triangle EDF equals to x squared equals to 52 over root 3 times root 3 over 4. So here root 3 over root 3 is 1, root 3 is cancelled, and 52 over 4 is 13. So we got that the area of triangle EDF equals to 13 square units. Okay, so we found out that the area of the equilateral triangle EDF equals to 13 square units. So now actually we can find out the area of the quadrilateral BDEC. The area of the quadrilateral BDEC will be equal to the area of triangle DBF, that is 8 square units, plus the area of the equilateral triangle, that is 13 square units, plus the area of triangle EFC, that is 15 square units. So in total, the area of the quadrilateral BDEC equals to 13 plus 8 plus 13 plus 15. 8 plus 13 is 21, 21 plus 15 is 36. So the area of the equilateral of the quadrilateral BDEC equals to 36 square units. Okay, but we have already found out that the area of quadrilateral BDEC equals to 3 times the area of triangle ADE. The area of quadrilateral BDEC equals to 3 times the area of triangle ADE. And we know that the area of quadrilateral BDEC equals to 36 square units. So from this equality, we can write that 36 square units equals to 3 times the area of triangle ADE. Here we can divide this equality by 3 and we will find out that the area of triangle ADE equals to 36 over 3, that is 12 square units. Okay? So the area of triangle AED, this triangle, equals to 12 square units, and now we found out the area of quadrilateral ADEC. Actually, the area of quadrilateral ADEC that we called the green shape equals to the area of triangle ADE, that is 12 units, 12 square units, 12 square units, and the area of the equilateral triangle EDC, that is 13 square units. So 12 plus 13 is 25 square units. Okay. again, the area of quadrilateral ADEF equals to 25 square units. Okay, now I will summarize the lecture. Actually, we wanted to find out the area of quadrilateral ADEF in the green color, and we know that in triangle ABC, angle BAC equals to 60 degrees, and also BF equals to CF equals to DF equals to VF, and we also know that the area of triangle BDF equals to 8 square units, the area of triangle CEF equals to 15 square units, and we want to find out the area of the green shape, that is the area of quadrilateral ADEF. Okay, so first of all we have rule number 1 that states that the sum of the angles in any triangle is equal to 180 degrees. So we actually defined angle ABC as B, and we defined angle ACB as C, and we know that angle ABAC equals to 60 degrees, and the sum of the angles in any triangle, and especially in triangle ABC, equals to 180 degrees. Okay, the sum of the angles, rule number 1 says that the sum of the angles in any triangle is equal to 180 degrees. That is to say, 60 degrees plus angle B plus angle C equals to 180 degrees. 60 degrees plus angle B plus angle C equals to 180 degrees. We subtracted 60 degrees from this equality, and we got that B plus C equals to 120 degrees. Okay, and then we have rule number 2 that states that in front of equal sides in the triangle there are equal angles. So if AB equals to AC, then angle ABC equals to angle ACB. Okay, so we actually, in triangle BDF, we know that DF equals to VF, DF equals to BF, and in front of side DF we have angle B. So in front of side BF that equals to side DF, there must be the same angle, because those two angles must be equal to each other according to rule number 2 that states that in front of equal sides in the triangle there are equal angles. So in front of these two sides we have those two angles. Those two angles are located in front of equal sides, therefore they must be equal to each other. So if this angle is B, then this angle must be equal also to B. Then we repeated on the same process on triangle EFC, this triangle. We know that EF equals to FC, therefore in front of angle EF we have angle C. So in front of FC we have this angle, so this angle must be equal also to C, because in front of equal sides in the triangle there are equal angles. So those angles that are located in front of equal sides must be equal to each other. So if this angle is C, this angle must be equal also to C. Okay, then we defined angle DFB as P and angle EFC as Q, and we expressed angle P and Q in terms of B and C. We know that the sum of the angles in any triangle equals to 180 degrees, so B plus P equals to 180 degrees. So 2B plus P equals to 180 degrees. We subtracted 2B from this equality and we got that P equals to 180 degrees minus 2B. And the same thing we did here. We know that the sum of the angles in this triangle is 180 degrees, so C plus Q equals to 180 degrees. So 2C plus Q equals to 180 degrees. We subtracted 2C from this equality and we got that Q equals to 180 degrees minus 2C. Then we added together Q and P, and P plus Q equals to 360 degrees minus 2B minus 2C. And then we got this equation number 2, that P plus Q equals to 360 degrees minus 2 times B plus C. And we know that B plus C equals to 120 degrees, so we can substitute B plus C in the equation number 2 by 120 degrees. We substituted it by 120 degrees and we found out that P plus Q equals to 180 degrees and also B plus C equals to 120 degrees. And then we have rule number 3 that states that the sum of the angles on a straight line is equal to 180 degrees. We used rule number 3 in order to calculate the angles ADE and angle AED. We know that AB is a straight line, therefore the sum of the angles on a straight line at a certain point must be equal to 180 degrees. So angle B plus 60 degrees plus angle ADE must be equal to 180 degrees according to rule number 3. Okay, so again, angle before we did it, actually we calculated the size of this angle. We know we use the same rule that states that rule number 3 that the sum of the angles on a straight line is equal to 180 degrees and BC is a straight line, therefore angle P plus angle Q plus 60 degrees must be equal to 180 degrees. Okay, angle P plus angle Q plus angle TFE, this is the missing angle, must be equal to 180 degrees according to rule number 3. Okay, but we have already found out that P plus Q equals to 120 degrees. So we substituted P plus Q by 120 degrees and then we substituted 120 degrees from this equality and we found out that the value of angle DFE is 60 degrees. This angle DFE equals to 60 degrees. Then again we have the rule that the sum of the angles in any triangle equals to 180 degrees, and the same thing is true for triangle DEF. But before that, we have here side EF in triangle DEF equals to side DF. So in front of equal sides there are equal angles. So those two angles must be equal to each other. And if we define one angle as y, then other angle must be equal also to y. So according to the rule that the sum of the angles in any triangle is equal to 180 degrees, then 2y plus 60 degrees must be equal to 180 degrees. Y plus 60 degrees equals to 120 degrees. Here we subtracted 60 degrees from this equality. we got that 2y equals to 120 degrees. Here we divided this equality by 2 and we got that y equals to 60 degrees. So this angle FDB equals to 60 degrees, and also angle FED equals to 60 degrees. Therefore, triangle FDE is an equilateral triangle. That is to say, all of its sides are equal to each other. And then, so if and this side is equals to x, then all other sides equal to x, and all the sides here are equal to x. Okay, and then we calculated the size of these angles in triangle ADE, and according to rule number 3, that states that the sum of the angles on a straight line is equal to 180 degrees. So actually angle B plus 60 degrees plus angle ADE must be equal to 180 degrees. Okay, angle B plus 60 degrees plus angle ADE must be equal to 180 degrees. We subtracted 60 degrees and B from this equality, and we got that angle ADE equals to C. Angle ADE equals to C. Then we repeated on the same process on the other side of the triangle. We know that AC is a straight line, therefore C plus 60 degrees plus angle AED must be equal to 180 degrees according to rule number 3. Okay, C plus 60 degrees plus angle AD must be equal to 180 degrees, and from this equality we got that angle B equals to this angle AED equals to B. Okay, angle AED equals to B, and we actually proved that triangle ABC is similar to triangle ADE because those two triangles has exactly same angles. The angles are 60 degrees, B and C. Here, triangle ABC has 60 degrees, B and C. So those two triangles are similar to each other according to angle similarity. And we have rule number 4 that states that the ratio between the areas of similar triangles is equal to the square ratio of the corresponding sides. That is to say, the ratio between the area of triangle ABC to the area of triangle ADE equals to the square ratio of the corresponding sides. The square ratio of the corresponding sides is actually BC square over DE square. Okay, and we know that BC equals to x plus x and DE equals to x. So we actually have here 2x squared minus x squared is 4. So we found out that the area of triangle ABC equals to 4 times the area of triangle ADE, this triangle. And then we calculated the area of quadrilateral DBEC. The area of quadrilateral DBEC equals to the area of triangle ABC minus the area of triangle ADE. Okay? Again, the area of the quadrilateral DBEC equals to the area of triangle ABC minus the area of triangle ADE. But we know that the area of triangle ABC equals 4 times the area of triangle ADE. So we can substitute the area of triangle ABC by 4 times the area of triangle ADE. So we got that the area of quadrilateral BDEC equals 3 times the area of triangle ADE. it is 3 times bigger than triangle ADE. And then I presented to you a rule to calculate the area of any triangle. The area of any triangle equals to A times B times sinus theta over 2. Okay? And here we have two triangles. The area of triangle EFC is 15 units, and the area of triangle DBF equals to 8 units. So we divided one area by the area of the big triangle by the area of the small triangle, and we calculated the area of the big triangle according to the formula that I presented to you. The area of the big triangle equals to x times sine q over 2. Okay, the area of the big triangle equals to x squared times sine q over 2, and the area of the small triangle equals to x times sine p over 2. X squared times sine p over 2. So we found out that sine q over sine p equals to 15 over 8. And then we have the equality that states that q plus p equals to 120 degrees. So q equals to 120 degrees minus p. So we can substitute q in this equality by 120 degrees minus p. Okay, so we substituted q by 120 degrees minus p in this equality. And then we calculated the value of sine 120 degrees minus p according to this trigonometric identity that states that sine A minus B equals to sine A times cosine B minus sine B times cosine A. And we found out that tangents P equals to 4 times root 3 over 11. Actually, tangents P is the relationship between the sides of a right triangle. It is the relationship between the side that is in front of angle P over the side that is near angle P, and we can calculate the size of the hypotenuse according to the Pythagorean theorem, and we found out that sine P equals to 4 times root 3 over 13. And after we found out the value of sine P, we can easily calculate the area. We can actually use the formula that I presented to you for the area of triangle BDF that equals to 8 square units. The area of triangle BDF according to the formula that I presented to you equals to x squared times sine P over 2. And we know that sine P equals to 4 times root 3 over 13, so we can substitute sine P in this equality by 4 times root 3 over 13. So we did it and found out that x squared equals to 52 over root 3. Okay? And the area of triangle EDF equals to x squared times root 3 over 4, and we found out that x squared equals to 52 over root 3, so we can substitute x squared in this equality by 52 over root 3. We substituted it and we found out that the area of the triangle EDF equals to 13 square units. The area of this equilateral triangle equals to 13 square units. After we found that the area of the equilateral triangle equals to 13 square units, we can find out the area of the quadrilateral BDEC because the area of quadrilateral BDEC equals to the area of triangle BDF, that is 8 square units, the area of quadrilateral of equilateral triangle DEF, that is 13 square units, and the area of triangle EFC, that is 15 square units. So in total, the area of quadrilateral BDEC equals to 8 plus 13 plus 15, that is actually 36 square units. Okay, but we also know that the area of quadrilateral BDEC equals to 3 times the area of triangle ADE. Therefore, we have this equality that 36 equals to, from this equality we can derive that 36 equals to 3 times the area of triangle ADE, and here we divided this equality by 3 and we found out that the area of triangle ADE equals to 12 square units. The area of this triangle equals to 12 square units. So, and the area of quadrilateral AEDF equals to the area of this triangle, that is 12 square units, plus the area of this triangle, that is 13 square units. In total it equals to 12 plus 13, that is actually 25 square units. So we found out that the area of the green quadrilateral AEDF equals to 25 square units. Okay, again, the area of the green shape, that is quadrilateral AEDF, equals to 25 square units. Okay, thank you very much.